Hi, good evening. How are you doing today? So, welcome to my daily live session on various methods and tools for execution excellence by changing mindset and culture on our journey of creating world class companies and exceptional leaders. I've been picking up one method or tool at random and explaining what it means and what way it can be used and what my experience using that particular tool or method is. Let me start by doing a very quick recap of what I explained on Friday, which is what I'll be doing first. And after that, I'll talk about what is it that we are going to be talking about today. Friday, I spoke about business process mapping. Basically, to talk about what is the objective. Why is it that one does business process mapping? That is sometimes many a times in organizations not rightly understood. Business process mapping is mainly for the purpose of any newcomer, anybody who is new to that particular company or department to be able to understand what way the job is done. It's not for getting a ISO certification, not to get a assessment score done. So that's not the objective at all. Therefore, it's important to really make a business process in the eyes and the way somebody new would be understanding, and not for the existing people to basically understand how the process runs. That is not required because the people who are already there are quite experienced. So there's no need for them to understand. So that's something which I had explained on Friday. And today, let us go to the next tool which I'll be talking about today, which is about drum, buffer, and rope. This is a methodology in TOC. So let me introduce theory of constraints. It's a very simple, commonsensical methodology which talks about every system having one single constraint which is limiting the growth. That's a very simple sentence which I said. One system having one single constraint which is limiting the growth, and once that constraint is addressed, then we could go to the next constraint. And how to address the constraint? There are 5 steps. First is to identify the constraint, and after that to maximize the constraint, which is to really ensure that the constraint is really working full time, full 24 hours. And after that, to subordinate everything to the constraint, which means that all the decision making, everything has to be taken based on the constraints availability, constraints suitability, whatever that is appropriate and more friendly to the constraint has to be prioritized. So that's the act of subordinating to the constraint. And the 4th step is to elevate the constraint, which is mainly to ensure that the constraint can produce more or can deliver more, so that the constraint becomes not really the constraint in the system. And the 5th one is again to go back to the step 1, which is to identify the constraint. That's the fundamental concept of theory of constraint. It sounds very logical. No discussion on that at all, and it is basic common sense. And in fact, there are situations where in a company there could be a constraint within the organization or could be outside the organization. If it is within the constraint organization, then it is easy because then we are trying to identify the constraint which could be blocking the delivery, or production or the execution of a particular task, which is a little more easier than trying to talk about an external constraint. Imagine the capacity in the organization is not fully utilized, which means the constraint is the market. Market is not able to pull the particular product. Therefore, one needs to work in marketing and sales to increase the demand for that particular product. So these are 2 different approaches in theory of constraints. And when we are trying to work within the organization to get the maximum benefit from the constraint, uh, one of the fundamental principles is implemented as a system so that one could manage that show without any problem. And that system is called as drum, buffer, rope method. Drum is the one which gives the beat, like you see in the screen here. It's something which is giving a rhythm, that is the drum. Buffer is something which is ensuring that there is sufficient amount of material or resources or inputs available for the constraint to keep working, even though the others have stopped for whatever reason, so that the constraint doesn't always starve. That is the basic principle of buffer. And rope is basically when the constraint itself is not working, there is no point in producing at all, because that is a constraint. Therefore, rope is something which is philosophically assigned to that activity which ensures that the production stops 100% when the constraint stops, because there is no point in producing. Constraint always is the one which produces and works the slowest. Therefore, when the constraints stop, there is no point in producing on the other machines, other stations where the cycle times are much lower, in which case the production inventories will get piled up, but it will not get delivered to the end customer. That's the reason why when the constraint stops, one has to stop. That is done by the philosophy of rope. Let me now try to explain on this picture. It's very simple. Imagine that there are 1, 2, 3, 4, 5 people walking, and the objective is that all the 5 should come to the end goal point at the same time. Only then they will win. It's not possible that only 1 or 2 come there and then they can win. So in this case, let us imagine that the red here is the constraint. Red person is the constraint. That means he's the one who's walking the slowest. He's the one who's, let us say, fat like me, or somebody who is not that athletic, so he's not able to walk fast. So he's the one who is walking the slowest. The ones in the front, the green ones, are walking very fast, and the blue ones are also capable of walking fast, but they are walking behind the constraint. Now, only imagine that all these guys are walking in a line for a beat. A beat is something which is talking about how fast you're walking, like the ones which you do in schools when we did the march past, and that beat is something which is giving the pace for the 5 people to walk. As they're walking, imagine that there is some kind of a issue with the constraint, right? Now we'll talk about first the drum. What is the drum? A drum is something which is ensuring that the beat is there, which is the one which is ensuring that the beat continuously happens. There is no problem with the rhythm. So that rhythm is created by the drum. And then what is the buffer? Buffer is, let us imagine that these 2 guys have a problem for whatever reason. Then this constraint can still continue walking till this point. You can give a buffer, so much buffer that is necessary for these people to again get up and walking. Let us say this guy slipped and fell down, or he had to remove a stone which got stuck in his between his feet and the sole of the sandals, for example. Then he had to remove the stone. Or maybe he just got an immediate telephone call and he just picked up the call, so he missed 1 step. So this guy did that, therefore this guy also stopped. But then the constraint should not stop. If the constraint stops, then the speed gets reduced. The entire speed depends on the constraint speed. And the principle is the constraint has to continuously keep running, keep walking. So therefore, let us say this length, what you see here, is the buffer. That means the constraint can still continue walking till this point, even though these 2 guys, one of these 2 guys stopped for whatever reason. Okay? That is what the buffer is all about. Then comes the next concept of rope. What is this rope? Imagine for whatever reason the constraint stopped. He had a problem. His shoe got stuck, or there was a stone in between the sandals and his feet. Therefore, he had to remove that. If that happened, then there is no point in these 2 guys continuing to walk forever. So therefore, there is a rope here. Moment that rope gets fully tightened, that means they come to the end of the rope, then they have to stop. They can't go further because the rope is tied to the constraint. So this is the concept of the rope. Drum, buffer, and rope. So these are the 3 things which are necessary in any production system. Whether it's a product company or a service company, anything where you are trying to produce, this is a very interesting and a very, very powerful concept. A drum which gives the pace, a buffer which defines the amount of input materials and resources that needs to be available for the constraint to keep working, and to ensure that this buffer is so planned that before the other machines can get rectified and new supply starts, that entire time required for correcting a machine which is not a constraint is the buffer. And rope is something when the constraint stops, everything has to stop. That is the buffer concept. So these are 3 things which I think is quite clear. There is no difficulty in understanding this concept per se. If you want to read a little more, then my recommendation is to read a book. I'll just type it out here. The book is called as The Goal, which is an introduction to the this book, The Goal, written by Eliyahu Goldratt. Let me also add that that possibly is something which is important, which is written by Eliyahu Goldratt. Okay, so that is what it's all about. Goal by Eliyahu Goldratt. This was written sometime in the 80s, if I'm not mistaken. So you read that book, then you can understand the concept of drum, buffer, and rope. That is the first fundamental principle which one needs to understand. That is the way this tool can be applied. Now, coming to the modern manufacturing, 80s to now, a lot of things have changed. Drum, to a great extent in the industry, is called as a pacemaker. Have you heard of that word? Pacemaker. Pacemaker is that operation in the company which is defining the pace for the entire organization. It's important to identify the pacemaker of the company. And it's quite interesting that the pacemaker need not be the constraint always. The pacemaker could be your assembly where your entire product is getting defined. That could be the pacemaker. Or pacemaker could be the heat treatment shop where the sequence of materials getting into the heat treatment shop and the size of the furnace, because that is important. Each furnace has got certain volume. So you need to make sure that all the components get in and the entire volume is used. Otherwise, it will not become cost effective. And that is the pacemaker. A pacemaker could be anywhere. The one which is setting the pace for the entire production to get processed. How do you check whether it's really the pacemaker or not? Very simple. Count what production is being done in each operation, and whichever operation production is equal to the output, is a constraint. That is very simple. You understood? Suppose there are 10 operations and each one is able to produce 100 parts an hour, and one machine is producing 120, the other one is producing 80, and finally at the end of the line, what quantity are you getting? If it is 80 per hour, then 80 per hour machine is a constraint, because that is the one that limiting the production to be increased to beyond 80 per hour. So that is the next one, which is drum was the pacemaker. Then the constraint is something which you understood. How do you define the buffer? Buffer you define by giving a let us say a long conveyor belt could be a buffer. A number of trays could be a buffer. You can say that in this particular behind this operation, I'm going to have 20 trays. That is the maximum I can have, and that you can limit it by having some kind of a rack structure. Or it could be a gravity feed conveyor where you have made the conveyor width in such a way that it accommodates that buffer. Or it could be a supermarket where you got the height limited. That limitation is the buffer. So these are all the buffer possible examples in the industry. What is the rope? That is very, very interesting. That's something which possibly you find it hard to imagine. How can a rope work in a manufacturing company? Let me explain two possibilities. One is you could have a supermarket wherein you are supplying the parts to a supermarket. That is typically the case if it is a retail company where you are trying to sell the products to multiple customers, and the products are more or less standard, or they are standard SKUs, and these SKUs are supplied to, SKU stands for stock keeping unit, for you to get an idea. And these SKUs are then sold to the end customers. So the SKUs are all standard. You are only basically replenishing the stocks, let us say. In such a case, you could define the minimum, maximum stock levels. And based on that, you could define three colors. One is green, red, and yellow. Green would be that the stock is acceptable. Yellow is almost there. Red is the stock is low. Moment it is red or below red, then you have the right to produce. If it is already in the green zone, then stop the production. That is the concept of rope. Okay, when it is stocked item. The other possibility is a discrete order. Discrete orders, what you do is you take the lead time and divide the lead time into three zones. And the first zone would be the green zone, and then the yellow zone and the red zone. Well, that is the lead time. Let us say the lead time was 20 days for a particular order. If the order is being processed today and it has to be delivered in the next 10 days, then it is still in the green zone. That means 12, let us say 12 is easier to calculate. 12 divided by 3 is 4. So 4 means up to 8 days of the delivery date, the order is still in the green zone. If it is between 8 and 4 days, that means when the delivery date is 20 and your actual date is between 12 and 16, then you are in the yellow zone. If the delivery date is 20 and you are between 16 and 20th of the month, then your zone is red zone. So when you are prioritizing the products and production in the shop floor, this is a very smart thing in the drum buffer rope method. You basically go in the sequence of red, yellow, and white, red, yellow, and green. Because red orders are all very, very urgent because they're very close to the due date. Those orders get priority. Then comes the yellow ones, which are little less priority. And then the last one is the green priority. Now there are further orders, which I use, call it as the white orders and the blue orders. Blue orders are those where the due date has already expired. That means I had to supply it yesterday, but I have not supplied. That is blue. I call it as blue because it's coma, is what I call it as. Because they're already dead. The entire thing is gone. So it's in a coma stage. Unless you really revive that and start supplying immediately, the customer will be lost. So that is getting the first priority. So in terms of priority sequence, it is blue, red, yellow, and green. Then what is below green? That means, let us say your lead time is 12 days. And from today to the delivery date, if it is 14 days, then it falls in the white zone. White zone is where it is lesser than green. White orders are prohibited to be started. That is the rope in the manufacturing. White orders you cannot start at all, because if you start the white order, then you are really building up inventory. It doesn't make any sense at all. Therefore, don't start the white order. Similar concept is also valid for stocking. Let us say if the stock is already reached the maximum green, anything beyond that becomes white. You don't need to produce something which is beyond green, and therefore that is the rope. So you got the concept now. Drum, buffer, and rope. Very simple. Drum is the pacemaker. Then buffer is the quantity you place behind the constraint. How do you identify the constraint? Find out what quantity is coming at the end of the line, and that quantity, whatever you are getting at the end of the line every hour, every day, every shift, that you match it to the production quantity of each of the machines. Whichever matches is the constraint. That is the first check. Second check is you walk through the shop floor and find out where the material is getting held up. That is the constraint. Where it is, there is a people keep debating. There's a big what should I say, intellectual debate on what is constraint and what is a bottleneck. Constraint, in my opinion, is very simple. Is something which really hinders you to supply more. That is the constraint for the system, for the entire company. Normally, there will be only one constraint. For the entire line, there will be only one constraint. Bottleneck are those machines where, for whatever reason, because of inconsistency, because of instability, you could be having a temporary phase where the machine would not produce at the same level and the same rate as what you need. Therefore, material gets piled up there. Now, the smartness in manufacturing is to ensure that the constraint always remains the constraint. Only then can you manage the shop floor. Otherwise, everything gets shifted here and there, and you really lose as to where the focus should be given. So constraint has to be ensured that it is always the constraint. Therefore, if in a particular machine, which is not a constraint, some maintenance issue happens, it's important to correct it immediately so that not to let that become a constraint. That's the smartness of managing a shop floor. I think many of you know that. Those of you who don't, you can write to me. Email is dinakar@samutana.com. I'll be more than happy to explain that concepts to you, that way to go about doing it. It's no rocket science. I said theory of constraint is absolute common sense. There is no real rocket science in that. So then you understood the concept of drum, buffer, and rope. My request is, those of you who have not tried it out, try it out tomorrow in your factories. It really gives you a phenomenal amount of peace, because once you have drum, buffer, rope implemented, your entire stress levels come down, because you don't need to really keep, there's no hectic there. It works like a clock, it's very, very simple. Of course, you need to have process stability before you do all this. That's something which I didn't speak about. Basically, technologically, the process should be stable. It's not possible that you have a process which is having a cycle time varying from 10 seconds to 18 seconds. None of the systems will work. Forget about everything. First is to set right that. The other possibility is you have a process where the first pass yield, which is the first time the part comes out and it is okay, and that first pass yield is varying from, let us say, 10% to 80% or 20% to 90%. And that is again a disaster. Don't try any system. Only focus on ensuring that that particular machine or the process becomes stable. And if it is, and when I say stable, it doesn't matter if you are producing with less first pass yield. As long as the first pass yield consistently stays at 80%, for example, there is no problem. The disaster is when it varies between 60% and 100% on various days, or 20% and 100%. That is dangerous, absolutely dangerous. That system, please don't do any kind of an improvement. Don't think of drum, buffer, rope. The first thing is to set right that. That is the secret which I want to share, because many times people don't do that at all. All these things can be done provided the basic processes are stable. That means you check the cycle time. It's again a very simple activity. You go to this particular machine, check the cycle time. Is it cycle time? If you check 20, if it's a manual operation, check it 10 times and find out what is the variance, what is the variation between the min and max. If the variation is between about 5% plus minus of the average which you got, then it's okay. It's something which is dominated. Otherwise, you need to work on the process, dominate the process first, then you think of drum, buffer, rope, or whichever other system you want to implement. Got it? And that's something which is my strong recommendation based on my experience. So having said that, and explain drum, buffer, rope, so let me now talk about what tool am I going to be talking about tomorrow before I end today's session. Tomorrow, my tool would be what? Let me see. Let us see here what comes up. Tomorrow is a different thing altogether. We are not talking about production tomorrow. Tomorrow, it's more generic in nature. We're talking about MBTI types. MBTI stands for Myers-Briggs Type Indicator. It's a psychological grouping of all human beings on Earth. And I'll talk about that. I'm sure it will be something totally different than technology and something totally different than numbers and mathematics and statistics. So Looking forward to seeing you again tomorrow, more or less the same time. And wish you all in India a very nice evening, and wish you, those of you outside India, a great day ahead. And see you tomorrow, more or less the same time, with the topic MBTI, Myers-Briggs Type Indicator. Thank you so much, and goodbye.